welcome to this week's tutorial video. What we are going to do today is what we call a hotspot analysis. So consider hotspot to be an analysis that performs to you perform to show where you have clusters and where you don't have clusters in any data that you are working with. So in the example that we have, I'm going to use the DC data again to perform this analysis, and I'm going to show you how to run the analysis step by step, and then also I'll show you how to use what we call a model builder to perform the same analysis, but in this case you can just build a workflow that you can reuse over and over again. So you are going to see that the process that we use involves a couple of steps, but you can also see that you can use the same steps if you build a model. Let's say this is an analysis that you do for every week for your police department. You can repeat this process every week easily without going through how many steps that it takes to build it, and that is what model builder brings to you. So first, as you can see, this is the burglary data. So if we really want to see this clusters or where you have what we call a hotspot or hot zone, then we need to perform a hotspot analysis. Okay. So in hotspot analysis, the first thing we want to ensure in any spatial analysis is pretty much ensuring that the data we are working with is projected. So as you can see, this data is already projected, so we are good with that. Now, the process that we use for hotspot will modify the data that we are going to use. So because we don't want to modify the original data, the best thing for us to do is to make a copy of this data first before we start doing the analysis, because some of the tools, as you will see, will actually make modification to the geometries of the data. So we don't want to mess up the original one. So the first thing you want to do is open up your toolbox, and then you're going to go to data management tools, and then you're going to go to features, and then you're going to see there's an option, there's a tool here called copy features. Double click that tool. The input is going to be your burglaries, okay, and then your output, make sure it's going into the DC crime data. It's there already, so let me change the name, just call it copy. All right, so it's going there. And now the tool is going to run it, and then when it's done, it's going to add that copy data to your map. So now we can uncheck the original one, which is the burglary or run, but now we are going to work with the copy version. Now, in hotspot analysis, you can actually see that when you have a crime can happen at one place and then it will happen again. For instance, like apartment, the apartment has the same address. The main apartment has the same address. So if you have 10 or 20 or 30 crime calls within the same apartment, they are going to be 30 points on top of each other. Also, even if it happens in front or they are close by, then what we can do is that we want to snap all the calls that are close by together, so we can show that that area is a hot zone. So the way we do that is to run a tool called integrate. And integrate is also under the data management. This is your toolbox. So if you don't have yours open, this is how you open the toolbox. It's the red icon over here. And then you're going to go to data management. And then under data management, you're going to go to feature class. And the feature class one, you're going to see there's a tool called integrate. Now what integrate is going to do is it's going to look at a bunch of points, and then the ones that are close together is going to snap all the calls that are close together, and then that is how we are going to perform the analysis. So bring that, your input layer here is going to be the copy. All right, and then here we are going to specify a distance for within which we say that if a point is, say, normally if we are dealing in feet, we say about 30 feet, but of course we are in meters, we are going to say let's just say 9.5, or we can just say 10 meters. So what we say, if a point is within 10 meters, snap them together. So the software is going to go through and then snap calls that are within the 10 meters together and add them as like one, or snapping them on top of each other. All right, so hit on OK on this to run that too. And what it's going to do is it's actually going to modify the existing data. That is the reason why we had to make a copy of the original one because this particular tool makes changes to the input data, which becomes your burglary copy data. All right. So now that the point has been able to snap them together, what we want to do is we want to now count the number of points that have been snapped together in each of those locations that the system created for us. So we are going to use another tool called collect event. Collect event is found under your spatial statistics tools, and then it's called collect event. Open a collect event. Your input for the collect event is going to be the burglary copy data because that is the one that the integrate actually snap them together. So hit that and then hit on copy. And then here we're going to send the output back over into the just call it the burglaries collect event. Okay, so now we have that. Save that data in the DC crime database and then run it. And when this tool is done, it's going to give you something like that. So here, the size of the point will indicate the number of points that were snapped together. So anything that is between this size is going to be 1 to 1.4, or here we are dealing with, so the classification is not really going to be right over here. But what it's giving you is that it's showing you how many points were snapped together. Now, if a less amount of points were snapped together, then the other thing we can do is that we can run the integrate tool again, but this time we can actually increase the snapping from, let's say, 10 meters to say 20 or 30 meters. So we can do that if we want to see a little bit more variation in the data. But here with the 10 meters, you can see that not a lot of the calls were actually snapped together. But if we open the attribute table of that, you're going to see the number of points. So here there's an I count. It will tell you how many points were counted at each of those points. So here, if I sort it by, let's say, sort this guy by descending. So we can see descending. You can see 8 is the maximum points that were snapped together at a particular place, and that is that area. Our eight points were snapped together. So here we are using 5 meters to do it. So we can we did the integrate at 10 meters. So that is what we are doing. But if we had increased it to say 30 meters, then most of those points would have been snapped together to help with that part of the project. So now that we've snapped those points together and we have the collect event, now we can actually use the collect event data to now run our statistics. Okay, so we can now run the statistics to run the hotspot. Okay, so here to run the hotspot, we are going to go into, still we are in the spatial statistics 2. We are going to go to we are going to go and run the hotspot, and the hotspot over here is found in the mapping clusters, and then you can see that you have a hotspot over here. So double click on the hotspot. All right, it's going to give you this data. Now your input is going to be the collect event. So hit on the collect event, and that is going to be your input. The input field is going to be the I count. All right, and then the output, let's send the output back over here. So we'll just call it hotspot. Okay, send that guy over there. And then what we are going to do is we are going to keep that we are going to keep the fixed band and then Euclidean distance, and then tell the software to run. And then once it's done, it's going to give us the data. It's going to give us an interpretation of this data to show where we have hotspots and where we have cold spot. All right, so now you can see the output. The output shows us that this area is where we have hotspot, and then we have another hotspot over here, another hotspot over here, another hotspot over here, and another hotspot over here. The yellows means that they are not of any closer proximity to each other, but that could also be because of our integrate tool was only using 10 meters to do the snapping, so that could result in that. But this is how you run the hotspot to show, and the blue is where you show that it's not. So if you take a look at your table of content, it will give you the colors to show the percentage of what it thinks is hot and percentage of what it thinks is not. All right. So that is how we run the hotspot. Now the way we have this data, now we can use that I count field to really run a bunch of other spatial analysis for us. So for instance, here there is actually a new one called optimize hotspot. So let's do the optimize hotspot. The same data is going to be the collect event, and then here we are going to call it hotspot, but we'll say optimize. Okay, so let's just say, oh, all right, let's just call it that. And then we are going to see analyze field is going to be the I count, and then we'll keep everything default, and then let the software run the optimized hotspot for us. That does is that it actually uses a cell to run. So here the optimize pretty much lines up with the original hotspot that we did. There isn't that much of a difference between that and that. So what shows that pretty much the data is the same regardless of the method that we use in in preparing that hotspot. But scientifically, this is how we run a hotspot too. Now, once we have the data from the I count, then we can use different spatial analysis tool to also look at the same data. So now we can use say with this data. So let's just use the hotspot one. If you open the attribute data for the hotspot, you can see that it has a bunch of different z-scores. So here the z-scores pretty much, the higher the z-score, and the higher the p-value, that means the higher the cluster. So the lower the z-score, and then the lower the p-score, that means you don't have a lot of hotspot. So now that we have this z-score value, we can actually use this z-score value to actually generate the what we call a continuous surface, like a density. All right. So let's go. Make sure your customize, and then your extension. Ensure that your spatial analysis is checked on. Okay. And now we can go to the spatial analysis tools, and then we are going to look for, let's say, IDW. So IDW is under interpretation. So open up interpretation, and you can see you have IDW. Open the IDW too, and then here we will say our input is going to be the hotspot. Okay, so we say hotspot is our input. Our Z value is going to be the Z score. All right, and then we'll give it an output, and then let's just call the output IDW, which is inverse this distance weighted. Let's say that. Let's keep the default and then take a look at the results. All right. And then what it's going to do is it's going to interpret the same layer for you in a different way to show you where you have the hotspot and where you have cold spot. So here it's showing you where you have the hotspots. So the places that are red are the places that we have the hotspot, and then obviously the green areas are places that are cold because we don't have enough clusters on those areas. All right. Now you can see that this thing blurs all outside of the boundary of DC. So here I'll show you down the line how we can restrict the tools to only work within the boundaries that we want them to work, and not bleed outside of where we are working. So for instance, here this guy, if we want to just change a symbol and look it very well, let's say I can use the stretch, then I say I want to use my favorite one, and it will look something like that. That's your heat map, and this is your hotspot density. But obviously I'll show you how to clip this guy outside, out of the data. So Here, let's see something. What I want us to do again is let's make a copy of the original data, all right? And then let's increase the snapping to see if the hotspot is going to change. So let's go back here, and then we are going to, so data management, we're going to go to features, and then we're going to make copy of the original burglaries, and then we are going to say copy to, okay? So burglaries underscore copy to, and then we are going to run that, and then the software is going to make a copy for us. When we have the copy, now remember step 2 is to run the integrate. So we are going to run the integrate on the copy number 2. By this time here, let's increase it to say 30 meters. So we are saying snap points that are within 30 meters together, and then let's see the outcome. So write that and then go OK on that. Now that is created for us. And once the step 3, after running the integrate, is to what? Is to go into spatial statistics tools. We are going to go to utilities, and then under utilities, we are going to go to collect event. And then when we go collect event, our input is going to be the burglary copy 2. All right, that's what has been modified. And then here we are going to call it burglaries collect event 2. And then run that one and see. Let's see if 30 meters makes a big difference than that. It doesn't really make that much of a difference, but let's see. Now that we have that data, we can now repeat and run the hotspot. So go back into spatial statistics, hotspots. Input is going to be the collect event 2. Then the field is going to be your I count. And then here we are going to call it hotspot 2. And then keep everything the same, but and then run it. And then let's see if it does. So here, if we take a look at this, you can see it is a little different. The hotspot actually spreads just a little bit more than when it was 10 feet because of what? How many points are being snapped together. All right. So changing the snapping value actually has an impact on how the data will result. So the next thing that we did was take that data, the hotspot data, and actually create a surface, so a raster data. And then so to do that, we went into the spatial analysis toolbox, and then what we did is we went into interpolation, IDW. Input is going to be the hotspot 2. The Z field is going to be our Z score. Our output is going to be IDW. Let's call this guy 2. And then one thing I want to show you is how to get that data to just snap along this. So on your 2, we see it says environment. Click on environment. When you do that, we are going to come over here, and then there's a spot called raster analysis. Click on raster analysis and you're going to see max. So click on the drop down, and then you're going to tell it to cut it using the police boundary. All right. And then the next thing we want is we are going to processing extent, change that one also to be the same as the police district. All right. And then hit on OK, and then run there too. So what we are telling it that when you are done, just cut the data along the police boundary. And you can see this one is different from the first one we did where the data was all over the place. This one is only within the police boundary, and that is because we went into the environment to set those up, and that is why we have it. So now if I do my symbology on this one here, it's going to just be within the boundary, and it's not going to bleed over it. All right, and then let me go over to my symbology, my display, make this one into a bilinear. Then OK, and that looks smooth. And that is how we perform a hotspot analysis. All right. So this is just running a hotspot, getting the data. You make a copy of the data. You run the integrate to, and then after running the integrate to, you run the collect event. And then when you are done with the collect event, then you can run the hotspot analysis too to see where you have hotspots and where you have cold spots. And then you can use the output. Remember, the input is just going to give you um, where those clusters are in terms of the points, and then you will use the output data to actually do the interpretation, and and that is how we run that. So go ahead and take that data and reproduce a similar one, and then send me a screenshot of the work that you do with the using the hotspot method, right? So just use the DC crime data to produce a similar thing, and send me um, send me a screenshot of your work. All right. See you in the next video. Bye.